Welcome to another deep dive. Today we're going to be talking about NVILA.
NVILA.
It's NVIDIA's new family of visual language models.
Right.
These are the AI models that can, analyze images, understand videos, even help robots navigate.
Yeah,
But the thing about them is they've always been really resource heavy.
they have.
Training them, fine-tuning them, even just using them
It's a lot.
takes a lot of computing power, which has kind of held them back
Yeah, it's kept them in research lab for a while.
from really widespread use, and that's where NVILA comes in.
That's right.
And our sources today are straight from NVIDIA,
Yes.
their research paper, and our own notes as we've been kind of digging into this.
Absolutely. So NVILA is all about efficiency,
Okay.
but it's not at the expense of accuracy.
So how do they pull that off?
Yeah.
That was the first thing that caught my eye
Sure.
was this scale then compress approach.
Yeah.
I mean, doesn't that seem kind of backwards?
It sounds counterintuitive.
Yeah.
But it's very clever.
Yeah.
Think about it this way. If you're trying to understand a really complex scene, would you rather have a blurry security camera image
Oh, definitely not.
or a crystal clear high-definition video?
High def all the way.
Exactly right.
Yeah.
More detail is always better. And that's what NVLA does. It actually starts by increasing the resolution of images.
What?
And it samples more frames from videos. It
Okay.
uses a technique called dynamic S2.
Okay.
And it uses that to capture a really rich visual understanding.
So it's like watching the scene in a movie theater versus on a tiny little grainy screen.
That's a great analogy.
Yeah.
But here's where the compress part comes in. After it grabs all that visual data, then NVLA compresses it. So it uses spatial pooling for images and temporal averaging for videos.
Okay.
It's kind of like packing a suitcase efficiently. You get the same amount of stuff in a much smaller space.
Okay, that makes sense. But how is this so different from what other VLMs are doing?
So traditional VLMs, they work with fixed lower resolution images or fewer video frames right from the start.
Gotcha.
But by scaling up first, NVLA can capture details that might otherwise be missed.
Yeah.
And then it smartly summarizes all those details.
Okay, and now this next part blew my mind.
Okay.
They're talking about potentially training a 7 billion
Billion,
parameter VLM
which is huge.
on a regular laptop GPU.
It's pretty amazing.
Is that even remotely possible?
Okay, let's manage expectations a little bit.
Okay.
Training a VLM that large is going to take time and resources, even with all of NVLA's tricks.
Okay, fair point. But it's at least more attainable than it used to be.
Absolutely.
Right.
Yeah, it uses some really, really cool technology to make this possible.
Okay.
One key factor is FP8 training.
FP8.
Yeah. Imagine you're switching from measuring in inches to centimeters.
Okay.
You're getting the same measurement, but you need less data to store it.
Right.
That's kind of what FP8 does.
Okay.
It uses lower precision numbers
Okay.
for some of the calculations, and that speeds things up by a factor of 2.
So it's like trading a giant textbook for a concise summary, but you still get all the important information.
Exactly.
Okay, cool.
Yeah.
And then there's dataset pruning.
Yes.
What is that?
It's like spring cleaning for your AI.
All right.
It uses a method called delta loss, and what that does is it identifies and removes unhelpful data from the training set.
So it's not just learning from more data, it's learning from the right data.
That is the key.
Okay.
This pruning, it actually speeds up training by another 2x
Wow.
without sacrificing any accuracy.
So how much are we talking here? What kind of cost savings are we looking at?
So the research paper claims a 4.5x reduction in training cost
Oh, wow.
compared to the previous models.
That's massive.
It's massive.
That is seriously impressive.
Yeah.
But here's what I find really exciting.
Yeah.
NVIL isn't just about being efficient.
Right.
It's actually unlocking some incredible new abilities, too.
It is. You're spot on.
Right.
Yeah. The research highlights 3 major areas
Okay.
where NVIL is breaking new ground.
Hippie.
Temporal localization.
Robotic navigation. Right. And medical image analysis.
Okay, let's unpack those one by one.
Let's do it.
First up, temporal localization.
Right.
What
Right.
exactly is that?
So temporal localization is the ability to pinpoint precise moments within a video.
Oh,
So imagine you're trying to find that exact moment when a basketball player dunks the ball,
yeah.
or when a specific event happens in a movie.
Right.
NVILA can tell you exactly when that happens.
Wow, so no more scrubbing through hours of footage.
No more scrubbing.
Sign me up.
Yeah.
What about robotic navigation? How does NVLA fit into that?
So NVILA is being used to develop robots
Okay.
that can navigate in real time using visual input and language instructions.
So you could tell a robot to go to the kitchen and get me a glass of water.
Exactly.
And it could actually understand and do that.
That's precisely it. And it's not just about understanding static environments either.
Right.
NVILA allows these robots to adapt to changing conditions and unexpected obstacles.
Mhm.
That is wild. Okay, and finally, medical image analysis. This one feels like it has the potential to be a real game changer in healthcare.
It definitely does.
Hmm.
NVLA M3 is a framework that brings expert models into the mix,
Okay.
making NVLA incredibly powerful for interpreting medical images,
Okay.
like X-rays and MRIs.
So we're talking about like more accurate diagnoses and more effective treatments.
That's the kind of impact we're talking about.
That's huge. Okay, so NVIL is clearly a huge leap forward in VLM technology,
It is.
both in terms of efficiency and all these new things it can do.
Absolutely.
But I'm curious, what are your thoughts on how this might impact businesses?
So the research paper focuses mainly on the technical side,
Right.
but the potential for businesses is huge.
Okay.
Imagine if developing VLM solutions became much more affordable.
Yeah.
That would allow companies big and small to tap into this technology.
That's a really exciting thought.
It is. And think about how much faster businesses could update and improve their VLM-powered products.
Yeah.
Imagine a chatbot that learns and adapts in real time,
Wow.
or an e-commerce platform that gives you a hyper-personalized shopping experience
Right.
based on what you're looking at.
I can already see the potential for some serious disruption and innovation there.
For sure.
And then there's this whole idea of edge computing,
Right.
being able to run these powerful models on less powerful devices.
Yeah.
That opens up a whole new world of possibilities, doesn't it?
Absolutely. Think about VLM applications in places with limited internet access,
Right.
like construction sites or rural areas.
Yeah.
The potential applications are practically limitless.
This is also fascinating.
It is.
But before we get too carried away with everything NVIL can do,
Yeah,
I think it's important to step back and consider the bigger picture.
for sure.
We've talked about its efficiency
Yeah.
and these amazing new capabilities.
Absolutely.
But how might this technology change the world around us?
That's a big question.
That's something we'll explore more in the next part of our deep dive.
Can't wait.
Stay tuned.
So before we went to the break, we were talking about all these ways that,
Yeah. Yeah.
NVIL could change the way businesses work,
Right.
open up all these new opportunities.
Absolutely.
So let's shift gears a little bit.
Okay.
Get a little more technical.
All right.
We talked about data set pruning earlier,
Yeah.
but I think it deserves a closer look.
Definitely. This is where NVIL gets really smart about how it uses data.
It does.
Mm.
It's a really, really clever approach.
So how does it work? You mentioned delta loss.
Yeah, delta loss.
Yeah.
Imagine you have two VLMs.
Okay.
A large one, we'll call it the teacher, and a smaller one,
Okay.
we'll call the student.
Right.
So delta loss measures the difference in how these two models perform
Okay.
on a specific training example.
So it's like comparing the answers of an experienced expert to someone just starting out.
That's a great way to put it. So if both models get the answer right,
Okay.
or they both get it wrong,
Yeah.
delta loss considers that example pretty neutral,
Okay.
not that helpful for training.
Okay.
But here's the interesting part. If the smaller student model gets the answer right,
Okay.
but the larger teacher model gets it wrong, that raises a red flag.
So the student is outperforming the teacher. What does that tell us?
It suggests that this particular example might be misleading or confusing,
Okay.
even for a really powerful model.
Gotcha.
These are the examples that NVLA identifies and removes from its training set.
So it's like taking out those trick questions on a test that trip everyone up.
Exactly. You don't want to be learning from the bad examples.
Yeah, even the experts.
Right.
Okay, so it's not just about getting rid of the easy examples.
Yeah.
It's about filtering out the ones that could actually be harmful
That's exactly right.
to the learning process.
You got it.
Okay. And what about the flip side?
Yeah, so if the smaller model gets an answer wrong,
Okay.
but the larger model gets it right, that indicates a valuable training example.
So it's a tough problem that pushes the student to learn.
Exactly.
Okay.
Those are the examples that NVLA focuses on,
Gotcha.
making sure the model is trained on the most informative and effective data possible.
Okay, so delta loss is all about making sure the training data is high quality, not just high quantity.
That's the key.
Okay, what about FP8 training?
Yes.
You mentioned that earlier.
Yeah.
But I'm still not entirely clear how it actually speeds things up.
Sure. Think of it like this. Computers use numbers to represent information,
Okay.
and those numbers have a certain level of precision.
Okay.
So the formats that are commonly used in AI training, like FP16 and BF16,
Okay.
they're kind of like using a ruler with incredibly fine markings.
Okay.
They're very precise, but they require a lot of data. to
Right.
store all those tiny details.
Lots of decimal places.
Lots of decimal places, very precise measurements.
Okay.
But FP8 is like using a ruler with fewer markings.
Okay.
You still get an accurate measurement,
Right.
but you don't need to store as much data.
So less data means faster processing.
Exactly.
Okay.
FP8 training allows for larger batches of data to be processed, and the calculations can be done much faster
Cool.
without sacrificing that accuracy.
Okay. Now we've talked about how NVILA makes training more efficient.
Right.
What about fine-tuning more PSIC? VLMs often need to be adjusted
Yeah.
for very specific tasks,
They do.
which can be a resource-intensive process.
Absolutely. And that's another area where NVILA really shines.
Okay.
One key insight is that different parts of the model,
Okay.
specifically the visual encoder, which handles images and videos,
Right.
and the language model,
Yeah.
often need to learn at different paces during fine-tuning.
Hold on. Learn at different paces. What does that mean?
It's kind of like when you're hiking up a mountain.
Okay.
Think about adjusting your step size.
Okay.
A small step size
Yeah.
means slower progress, but you're more stable,
Mm-hmm.
less likely to stumble.
Right.
Larger step size, you move faster.
Yeah.
But you might overshoot your target.
So NVILA is basically fine-tuning different parts of the model
Yep.
with different levels of aggressiveness.
Yeah, that's a good way to put it. The visual encoder typically benefits from a much smaller step size or learning rate
Okay.
than the language model.
Gotcha.
And that prevents it from overfitting to the new data
Okay.
and makes sure that it retains its ability to accurately process all that visual information.
Smart.
Yeah.
Are there any other techniques that NVILA uses to make fine-tuning more efficient?
There is. So instead of using traditional methods like LoRi,
Yeah.
which can be really memory intensive,
Okay.
NVILA uses a technique called layer norm fine-tuning.
Layer and norm. What is that?
It's a way to normalize or balance the values within a neural network layer.
Okay.
Think about making sure that all the instruments in an orchestra are playing at a similar volume,
Okay.
so you can hear each one clearly.
Gotcha.
So how does that help with fine-tuning?
Yeah.
Layer norm is computationally much lighter
Okay.
than LoRi,
Okay.
meaning it requires less memory and processing power.
Gotcha.
But here's the kicker. It still delivers comparable performance. So that means NVIL can be fine-tuned on GPUs with less memory,
Right.
making it accessible to a much wider range of users.
I love that. It's like democratizing access to this technology.
Exactly.
Okay, so we've covered efficient training.
Yep.
We've covered fine-tuning.
Uh-huh.
Now let's talk about deployment.
All right.
This is where the rubber meets the road, right?
Yeah.
Actually using this in real-world applications.
You got it. And this is another area where NVIL excels.
Okay.
We've already talked about its ability to run on less powerful devices,
Right.
but there's more to it.
Okay. I'm intrigued. Tell me more.
So NVIL uses a specialized inference engine,
Okay.
and that's basically the part of the model that makes decisions based on the data it's given.
Okay.
This engine leverages quantization.
Okay.
Remember, that's like switching from a high-resolution ruler
Right.
to one with fewer markings.
It's like FP8 training, but for deployment?
Exactly.
Okay.
This reduces the computational workload during inference. That is when NVILA is actually being used to analyze those images. Videos understand language.
Right.
That leads to much faster response times and lower energy consumption.
So it's not just about making NVILA easier to train and develop,
Right.
but also about making it practical to use.
That's the goal.
In everyday situations.
Make it work in the real world.
Okay, so we've covered a lot of the technical aspects of NVLA.
We have.
But I want to circle back to something we discussed earlier.
Sure.
Those incredible new capabilities it unlocks.
Oh, yeah, you mean temporal localization,
Yes.
robotic navigation,
Uh-huh.
and medical image analysis.
Those are huge. They feel like entirely new frontiers.
They're not just incremental improvements.
VLMs.
Right. These new capabilities are a direct result of NVLA's innovative architecture.
Yeah.
And all of those efficiency gains that we've been talking about.
Okay, so let's start with temporal localization.
Right?
This is the ability to pinpoint specific moments in a video.
Yeah.
I'm still amazed that that's even possible.
It's pretty cool. It boils down to NVLA's ability to process a larger number of frames
Okay.
from a video
Yeah.
and its use of what we call discrete time tokens.
Time tokens. What are those?
Think of them like timestamps embedded within the visual data.
Okay.
They allow NVLA to actually track the flow of time within a video.
So it can answer questions like, when does the player dunk the ball?
Exactly.
Or when does that scene in the movie start?
Precisely. With incredible accuracy.
That's like a super-powered search function for video.
That's a great way to think about it. And this
Yeah.
has massive implications for all sorts of applications.
Yeah, like what?
Think about video editing,
Okay.
analyzing large amounts of video content, even security and surveillance.
Wow, I can see how that would be valuable. Okay, next up, robotic navigation.
Yes,
We touched on this a little bit before,
we did.
but I'm eager to hear more about how NVILA is actually helping robots
Uh-huh.
understand the world around them.
So this is where the NVILA framework comes in. It takes advantage of NVILA's strengths in processing visual information and language instructions
Yeah.
to guide robots through all these complex environments.
So, like, if you could give a robot a verbal command, like, go to the kitchen and bring me a glass of water,
Exactly.
NVILA would allow it to understand the command, but also visually identify the kitchen, navigate there, and even recognize a glass of water.
That's right. And it's not just about understanding those static environments either.
Right.
NVILA allows those robots to navigate in real time, reacting to changes and obstacles as they go.
It's like it can think on its feet.
It can.
That's incredible. Okay, and finally, medical image analysis.
Yes.
This one really captures my imagination
Yeah,
because of its potential to really transform healthcare.
I agree. NVILA M3, which incorporates expert models into NVILA.
Yeah.
It's already showing really promising results in medical image interpretation.
So instead of relying solely on a doctor's visual inspection,
Right.
NVILA M3 could analyze an X-ray or an MRI, pinpoint subtle abnormalities,
Yeah.
and even suggest possible diagnoses.
That's right.
And because NVILA is so efficient, these analyses could be done quickly
Yeah,
and on less powerful devices,
absolutely.
making this technology accessible even in areas with limited resources.
Exactly.
Yeah.
It's really exciting to think about how this could revolutionize healthcare.
Yeah, making it more accurate
More accurate.
and accessible for everyone.
That's the goal.
Okay, so we've talked about how NVILA works.
We have.
We've talked about its efficiency and all these amazing new capabilities.
Yeah.
But I think it's important to take a step back
Okay.
and consider the bigger picture.
The big picture.
What are the larger implications of this technology?
Right.
How might NVILA impact society, the economy, the way we live our lives?
All big questions.
That's something we'll delve into in the final part of our deep dive.
Looking forward to it.
All right, so we're back, and we've spent the last two parts of this episode, really unpacking NVILA
Yeah, we've gone pretty deep.
from, the efficiency tricks to those mind-blowing new abilities.
Absolutely.
But now I want to talk about the big picture.
Okay.
How might NVLA impact the world around us?
That's the million-dollar question, right?
Yeah.
We've seen how it works, but the real power is in, how it might actually change society, the economy, our everyday lives.
Let's start with society. How could wider adoption of VLMs like NVLA shift the way we live, work, and interact?
Imagine a world where visual information is just as searchable and analyzable as text is today.
Oh, wow.
NVLA's ability to understand those images and videos could revolutionize everything from how we learn and entertain ourselves to how we approach things like healthcare and security.
It's like giving our digital world a whole new set of eyes.
Yeah, eyes that can understand the visual language that surrounds us.
That's a great way to put it. What about the economic impact?
Sure.
We talked about, NVLM making VLM development more affordable for businesses.
Right.
But what about the workforce as a whole?
That's a big one. On one hand, this increased access to VLM technology could spark a wave of innovation, create all kinds of new jobs in fields we haven't even imagined yet.
It's like the early days of the internet.
It is.
Yeah.
Nobody could have predicted, the rise of social media or e-commerce back then.
Right.
But we also have to be mindful of potential job displacement
Yeah.
as VLMs start to automate tasks that humans currently do.
Makes sense.
This is something we need to be thinking about now,
Yeah.
making sure workers have the skills and the support they need to adapt to these changes.
It's a double-edged sword.
It is. The technology itself isn't inherently good or bad.
Right.
It's all about how we choose to use it.
Okay, so we've talked about the potential societal and economic impacts.
We have.
But there's one more piece I want to touch on before we wrap up.
Yeah.
You mentioned earlier that NVL could be used in places with limited internet access,
Right.
like construction sites or rural areas.
Uh-huh.
Can you expand on that a bit?
Absolutely.
Yeah.
That's one of the really exciting things about NVLA's efficiency. It has the potential to bring all that power of VLMs to the edge.
To the edge.
Think about a construction site
Okay.
where a robot powered by NVLA could navigate these really complex environments,
Wow.
assist workers with dangerous or repetitive tasks,
Yeah.
all without needing a constant internet connection.
That's an amazing application.
It is.
It seems like that edge computing capability could really bridge the gap between, cutting-edge AI research
Yeah.
and the real-world challenges that people face in all these different industries and locations.
It opens up so many possibilities.
Like what?
Remote healthcare diagnostics using portable devices,
Oh, wow.
personalized education experiences
Yeah.
in underserved communities.
So we've gone from unpacking the, technical nuts and bolts of NVLA
We have.
to exploring its potential to revolutionize everything.
Pretty much.
Healthcare, construction, even how we design our cities.
It's been quite a journey.
It really has.
Hmm.
As we wrap up this deep dive,
Yeah.
what's the one key takeaway you hope our listeners walk away with?
I think the biggest takeaway is that NVLA represents a huge leap forward
It does.
in VLM technology, not just in terms of efficiency,
Right.
but also in its potential to unlock all these new capabilities and applications.
Yeah.
It's a reminder that the field of AI, it's constantly evolving, and the possibilities are really only limited by our imagination and our commitment to, responsible development.
That's a great point. And it's something for all of us to think about as this technology continues to advance. Well, folks, that concludes our deep dive into NVILA. We explored its, technical brilliance, mind-blowing potential, and those far-reaching implications.
We covered it all.
It's been an exciting journey, and I hope you enjoyed it as much as we have.
I did.
Thanks for joining us. Until next time, keep exploring and keep asking questions, because that's how we make sense of this crazy world.